So this is the relationship for Taylor series, and this is the relationship for Maclaurin series. So Taylor series is used to represent a function about any point A, while Maclaurin series is a special case of Taylor series where A is equal to 0. So if you look clearly at the Taylor series, you can see if we replace A with 0, we'll end up with this Maclaurin series. So let us see example for each of the series. So the first example we are going to consider is finding the Taylor series of sin x about the point A is equal to pi. So considering this general formula, our f of x will just be f of A, then we have f prime of A, then x minus A, then we have f prime prime of A, then we have s minus A squared all over 2 factorial. So that is how the series will keep on going up to infinity. So now we know that our f of x is equal to sin x. So I have to find the derivatives. So I have cos x here. The second derivative will be minus sin x. The third derivative will be minus cos x. And the fourth derivative will be sin x. So you see the fifth derivative will then go back to the first derivative. So I need to find the values for this about the point A is equal to pi. So I will have f of pi will just be 0, f prime of pi, that is if I substitute pi here, that is cos pi, I will have minus 1. So f prime prime of pi will be 0. Then I have f third derivative of pi will then be 1. Then f4 of phi will be 0. So as I said, my f of pi will be the same thing as f of 1. My f of 6 will be the same thing as f of 2. My f of 7, because it repeats itself. So now I need to substitute these values in my series. So I will end up with f of x is just my f of A, which is f of pi, is just 0. So I will have minus, then I will have s, my A is pi. Then for the second, I have 0. X minus pi squared over 2 factorial. X minus pi over 3 factorial. Then for the fourth one, I have 0. So plus 0 x minus pi 4 over 4 factorial. So that is how it will keep on going up to infinity. So now if I reduce this, for all the zeros I will remove them. So I will have f of x will just be minus x minus pi. Then I will have plus x minus pi cube all over 3 factorial. Then minus x minus pi all over 5 factorial. Then I will have plus x minus pi to power 7 all over 7 factorial, and it will keep on moving. So since the function keeps on moving up to infinity, I can actually write it in form of summation. So my f of x, I can write it in form of summation of n is equal to 0 and it goes up to infinity. So you can see in each case I have x minus pi, x minus pi. So I can have x minus pi here. So for the powers, I have, starting from 1, I have 1, I have 3, I have 5, I have 7. So that is how it keeps on moving. And I start my numbering from n is equal to 0. So the first term will correspond to n is equal to 0. The second one to n is 1, n is 2, and n is 3. So you can see this is an arithmetic progression where the common difference is 2. 5 minus 3 is 2. 7 minus 5 is 2. So if I use Tn is equal to a plus n minus 1 d. So the first term, that is the first term, not the zeroth term, is 3. So I will have 3 plus my n, and the common difference is 2. So I will end up with 3 plus 2n minus 2, which is just 2n plus 1. So it means I will end up with 2n plus 1. Then the denominator also, it has the same progression, 1, 3, 5, 7. So I will have 2n plus 1 factorial. So now I need to deal with this switch in sign. So it started from negative, then it moves to positive, then negative, then positive. So I can deal with that using minus 1 to power n plus 1. So when n is 0, I will have negative. When n is 1, I will have positive. So that is how it will keep on progressing. So this is the Taylor series of sin x about the point a is equal to pi. So now we want to find the Maclaurin series of f of x is equal to cos x. As stated earlier, Maclaurin series is just a special case of Taylor series where a is equal to 0. So for Maclaurin series, I will just have f of x is equal to f of 0, then plus f prime of 0, then I will have x, then plus f prime prime of 0, s squared over 2 factorial, plus f prime 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 of 0, s cubed over 3 factorial. So that is how it will keep on moving up to infinity. So my f of x is cos x. So I will have my f prime of x as minus sin x, then f prime prime of x as minus cos x, then f prime 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 of x as sin x, then f4 of x as cos x. So I just need to find the f of 0 since I am dealing with my Maclaurin series. So cos 0 is just 1, then f prime of 0 is just 0, f prime prime of 0 minus 1, f third derivative of 0 is 0, then f4 of 0, I will have 1. So this will be equal to f of 5, 6, f of 7, f of 8, because it repeats itself. Now substituting into this f of x and considering the 0 values, I will end up with my f of x. I will have 1 minus s squared over 2 factorial. Then I will have 4 factorial. Then I will have minus s 6 over 6 factorial. then plus over f factorial. So that is how it will keep on moving up to infinity. So you can see that the series also have a pattern. It also have a switch of sign from positive to negative, and the powers increase by 2. So it starts with s to power 0, then s to power 2. So basically, I can also write it in form of summation to infinity because it moves up to infinity. So I will have f of x summation of n is equal to 0 to infinity. You can see in each of the values I have x to power 0, s to power 2. So I will have x, then I have 2n, then divided by 2n factorial because they have the power is the same thing as the denominator with factorial. So for the switch of sign, I can use minus 1 to power n. So starting with minus 1 to power 0, I will have positive, then minus 1 to power 1, I will have negative. So that is how it will keep on moving up to infinity. So this is the Maclaurin series for the function f of s is equal to cos x. For more comprehensive tutorials on engineering mathematics, watch the playlist on the screen. Please like and subscribe to the channel. Thank you for watching.